Hello, my name is Ato Tara, a lecturer in landscape architecture at RMIT University, and I'm representing a multidisciplinary team of landscape architects, engineers, and scientists who have collaborated on this research. I present a workflow which allows designers to engage with hydrologic and hydraulic properties and performance of landscape through an iterative and scientifically informed process. The pace of rural to urban migration, abundance of informal settlers living in hazardous areas, and limited adaptive capacity are particularly severe in the context of the small island developing states in the South Pacific. They are geographically isolated, have a small economics with limited urban infrastructure and institutional capacity. Honiara, Solomon's island capital in Melanesian region of the South Pacific, has no exception. With a history of colonization, ethnic conflicts, and governmental malfunction aligned with rapid urbanization, Honiara is living daily with disasters. Over one-third of its residents inhabit informal settlements on precarious land with lack of basic utility services. In April 2014, a slow-moving tropical depression caused persistent heavy rain in Solomon Islands. The rain caused flash flooding in Honiara and Guadalcanal. More than 750 millimeters of rain was recorded over 4 days. The flooding was the worst in living memory. It resulted in 22 fatalities, destroyed 672 houses, and affected approximately 52,000 people in the country. Nature-based solutions comes at first priority in Honiara context to achieve win-win situation between social, ecological, and economic systems that may lead to decreased vulnerability and increased resilience of cities facing climate change. NBS provides a framework to manage and minimize flooding using both natural and structural at multiple levels, including watershed, floodplain, community, and household. These actions fall into two main strategies, including reducing and managing the flow, improving drainage and protection in a floodplain. Small cost-effective multi-purpose dams, checkpoints, sand groins, gabions, channeling, contouring, and reforestation are considered a suitable solution to manage flooding in Honiara. In this research, we focused on Matanico River catchment and Barra Creek, a flood-prone tributary gazetted as an informal settlement zone. Land cover changes due to logging activities have led to major landslide and debris flows into streams and rivers. The increasing overland flow and localized flooding is a critical threat to these settlements. We employ GIS to interrogate hydrological system through the use of digital elevation model as an input to study a stream network hierarchy in landscape, catchment, and subbasins. Any intervention in pour points would result in flow changes within the watershed area. We demonstrate this workflow by generating multiple scenarios to reduce the impact and mitigate flooding within the catchment. Possible design scenarios for flood mitigation are focused on the ability to control the amount of water in upper stream catchment area to reduce surface runoff and that feeds tributaries streams within populated areas. The novel contribution offered is an ability to test the relationship between hydrological assessment and spatial suitability analysis to guide the design direction. This modeling is an example of proposing detention basins with 5-meter dam walls along major streams to capture the rainfall. It calculates the area of inundation and the volume of water that can be collected in each potential dam location. Design scenarios can be applied to the existing topography in different ways. A simple and interactive way to modify raster elevation model is to using a plugin in Adobe Photoshop called Geographic Imager, which retains the geographic projection of GIS rasters to modify the landform using eyedropper and brush tools. Modification of DEM allows for hydraulic analysis of landscape to understand performance of proposed nature-based solutions. HECRAS, developed by the U.S. Army Corps of Engineers, allows to perform one-dimensional and two-dimensional flow hydraulics. The 2D flow modeling is achieved by adding the 2D flow area into the model. Other input parameters include precipitation and flow hydrographs for boundary conditions as part of the unsteady flow data. These data are usually available through agencies or local governments, which will be monitored and collected during flood events. In absence of flow hydrographs in Honiara, we applied the simplified modeling of the rainfall based on rational method to simulate the 2014 storm situation, which was a 1 in 500 years flood event. Series of simulated intervals for the existing condition during a time period can be presented as an animation to understand how system reacts to rainfall situation. Accumulation of all intervals can define the maximum water depth can be used in flood risk analysis. Outputs of modeling in HECRAS result in maps of water surface level, depth, velocity, flood risk, which can be produced and exported as rasters to GIS platforms. The modeled flood risk can be verified by extent of previous flood events in order to calibrate modeling results. This demonstration shows a simple and quick application of HECRAS in a short time frame to simulate the depth and velocity within the 2D flow area. The simulated flood modeling for the before and after MBS conditions shows the effectiveness of these strategies in reducing flood depth along Barra Creek and Matanico River to reduce runoff and flooding up to 6.67 meters within the catchment. In the wake of climate change, nature-based solutions and flood modeling in HECRAS offers opportunities for landscape architects to test design options through the act of reshaping terrain in optimizing and maintaining landscape performance. Thank you.